Hello, welcome to this webinar. My name is Andrés Lesmes and I am an application engineer for DesignPoint Solutions. Today we're going to be taking a look at how to reverse engineer using the Geomagic for SOLIDWORKS add-in. In a previous occasion we saw how we can generate scan data using another software also by Geomagic, the Geomagic wrap software. Well, in this occasion, we will take that scan data that we got in wrap and we polished also, we cleaned it up in wrap, and we're going to put it into SOLIDWORKS and we're going to generate a 3D model for that. But first, let's take a look at our agenda for this webinar. We're going to be going through the 4 different steps, which are planning, extracting sections, generating the different features, and then in the end, of course, conducting a deviation analysis. So let's start with planning. Why do we have to plan? Well, as with anything, if we don't plan, we'll end up going in all kinds of directions and we're not going to be focused. So in this case, we have to do the same thing. Let's jump on to SOLIDWORKS and let's take a closer look at this. You'll notice that in my feature tree, I have a headphone piece feature, and also the surface bodies folder contains a surface. That's my scan data, but this is not really a surface. You notice I cannot click on it, so we'll have to rely on other tools in order to get something valuable for my modeling process out of these scan data. Just like with anything else in SOLIDWORKS, there are a lot of different ways in which we could model this part. If you had this part in your hand, just like I did, you would probably think that a couple of boss extrudes would be more than enough to model these, but it's actually a little bit more complex than that. We could utilize solid modeling techniques. We could utilize surface modeling techniques and be a little bit more precise, probably. We could either use that or a hybrid technique, which would involve a little bit of both. But inside of all of those 3 categories or techniques, there's a lot of different tools that we could use. So would I use a boss extrude for that? Would I use a sweep? Is this a loft or a boundary? What really is the best tool in order to model these? Well, let's dig a little bit deeper here. The first thing that I want to show you is that this model has a curved face along this edge. And if I use a boss extrude, of course, you'll know that I'll end up with a straight face. And I would have to delete that face after the fact and using surface modeling tools to generate that curvature. So that's one way in which I could approach that. I could probably use a lot of different surfacing techniques in order to get these and make it a little bit more accurate, but after looking at this model for a long time, I discovered that creating sections along these areas that I'm showing you right here would be the best way to approach it. That way we can create a loft. A loft, of course, as you know, it's constructed of multiple profiles. So we need to extract certain sections in order to do that. So that's in fact the second process in our PowerPoint, extracting those sections. So how do we do that in SOLIDWORKS? Let's go back to it and let's see how we can generate those sections that we're going to use for our loft. Well, first of all, I'll open up a sketch in my front plane. I'm going to create a spline that it will trace, not 100% accurate, but I'm just going to trace the outer profile of these. And the reason why I want to sketch these spline is because I'm going to be generating certain lines that I want to be perpendicular to the spline that I'm creating. So this is only for reference, really. It doesn't matter if I'm not 100% accurate. And in the end, I'll actually fix these splines so that the lines that I create afterwards won't affect it once I add the perpendicular feature relation. So I'm fixing it right now. Now I'm going to start adding all the different lines. And the reason why I create these lines is because each one of these lines will help me create a plane. The planes are what I will use in order to generate the section. Sections that are the intersection between that plane, which is infinite in length, and my scan data. Alright, so I have 5 different lines that represent the planes that I'm going to create. I'm adding a perpendicular relationship between them, and now I need to make them equally spaced. The first thing that I thought was, well, I can add an angle between these lines and add the same angle to everything, but that wouldn't work because this area right here is actually less curved. It has less curvature than the bottom piece, so the angle actually is greater towards the bottom and less on the top. So what I'll do in this case is I'll just create some construction lines between them, just straight lines that are construction, and I'll add an equal relation between all of them. So I'm going to select all of them, not the spline but the line, there we go, and then I'm just going to add the equal relation between all of them. That will ensure that they are equally spaced, and I'm not using an angle. Okay, so let me rotate this model a little bit because I noticed that there is a surface in my part that is a little bit lower than this surface in the edge right here. So I want this line to be below the portion of the model that will go a little higher, the face that is going to go a little higher. So I want this line to be just below that detail over here. Let me rotate it a little bit more and drag that up so that it's just a little bit below. Well, if I pull these out now, it's going to expand the one on the top that I just fixed. So what I'll have to do is to fix this line right here and then bring this one down and make sure that it's where it needs to be. I'm going to have to zoom in here a little bit more and actually drag it from the point. It looks like I'm editing this spline. There we go. Okay, yeah, that's going to be enough. I'm going to fully define these in order to make them stay on the spot that we want. I would probably be adding dimensions myself, but in this case, this is just for reference, so I'm going to just use the fully define command. Okay, so now I'm ready to exit out of this sketch, and I will need to create a plane that is coincident to each one of the entities that I have in this sketch. For example, this one, and I have to make it perpendicular to the front plane. Let me actually show it right now. Well, why do we need those planes? Well, it just happens that in my cross-section tool under my Geomagic for SOLIDWORKS tab, I have the mesh already selected, but I need to create the cross-section using a plane that I don't have right now. The only plane that I have shown at this point is the front plane, and that doesn't help me. So I need to create multiple planes using these selections. So let me go ahead and create a plane. As I explained before, I'm going to create multiple ones. So let me pin this up. Those planes are going to be coincident to these sketches and perpendicular to the front plane. So I'm going to hit OK. And by default it wants to generate another one as an offset, so I have to clear that and then move on to the next one. I'm going to click on that one, make it coincident, and then click on the front plane and make it perpendicular. Alright, so this is going to be the same thing for all of them, so let me speed this up a little bit. I'm just going to finish creating the other planes and then we should be ready to go now. Okay, perfect. So I have these planes that I generated. I can just hide the sketch now, and those are the planes that I'm going to use in order to get the sections that we need. So if we go now to the Geomagic for SOLIDWORKS tab, back to our cross-section tool, I'm going to choose the first plane that I generate here, this one right here. It extends the plane, and now I see a preview of the cross-section that I will get from the scan data. Alright, I have a couple of options here in the property manager. I can get these sketch as a polyline, as line as an arcs, or as a fit spline. I've had better luck with polylines only, so I usually go with that, and then I just clean it up as I need, or I trace over that. I'm going to leave the add fixed relation option checked. I'm going to hit OK, and then I get a sketch in my feature tree with the line that you're seeing right here. Once again, we'll do the same thing for all of these ones, so I'll just speed up the process here so you guys don't have to see me doing these very slowly all the way through it. Okay, so we have all the different sketches. I can hide the planes now, and I'm going to also hide the mesh. We have the different sketches that we're going to use to create the loft. There's some extra geometry here that was generated because probably these two sketches, the planes also cut the scan data on the other side, so that's why we have to, but we can just delete that in a little bit. So that's it for step number 2, extracting the sections. We can move on to generating the features, which is the third step. We're going to need to make those features in SOLIDWORKS in order to have the parametric model. Okay, so back in SOLIDWORKS, we're going to edit the first sketch that I have here, and I'm going to go normal to it so I can see it. And you see the sketch is open right now. I have this one sketch as a polyline, and that's because of the option we chose when we generated the cross section here with our tool. Right, so there are some imperfections here, so that's why I choose to have this as just construction geometry that I can trace over. So what I'll start doing is I'll start with a 3-point arc for the section here that is curved. I'm going to try to aim to the endpoints to what would be the virtual sharp. Once again, I have to be 100% precise. As long as it overlaps enough, I'm going to be fine with it. You can spend more time and add dimensions as you wish, and really trace 100% over that, but you're probably going to capture some imperfections from the scan data and even from the molded piece that, of course, it's not going to be 100% perfect either. So I'm just going to finish my closed contour and then start adjusting all these lines. There's some curvature here, but I'm going to leave that portion straight. I'm not going to create the fillets. I'm going to add those afterwards. So I'm just, once again, just adjusting my geometry to overlap as close as possible to the cross section that I have here. I'm not going to model the internal details as of right now, so I'll just leave this section completely closed and straight. Okay, a couple more retouches here and there, and we should be ready to go. Let me probably just pull these to the left a tiny bit. Okay, that seems pretty good. So this is the sketch that we're going to use to start the loft. You can add all the dimensions to make it fully defined. I'm just going to use the fully defined tool right now. So I'm going to let SOLIDWORKS take care of fully defining that for me. And this is just an example, but you can take your time and do it as precise as possible as you want. So we have the first section. We would do the same thing for all of them. So once again, I'm just going to speed up through that so that you don't have to see the whole thing. So I'm going to go normal to the second sketch, hide the first one, and then do the same thing for all of them. This is a very good way to go about it, not capturing the fillets. And the reason why I like doing that is because then later on in the process I can add individual features for the fillets. Just to give you an example, I'm not creating the sketch here with the internal pieces because I would want to create cut extrudes and shell features in order to capture that. So keep all of that in mind as you go through the process of creating your sketches and creating all of the different features. So this is the last sketch that I have to clean up right now, and we have them all now. So here we have it. This is the 5 different sections. They're cleaned up already. I'm going to show the scan data for you guys, and you can see how it overlaps really well. So the next process, of course, would be to start creating the loft. So being really careful that you choose the points the same corner on all of the different sketches. We can start to see how the loft would be constructed. You get the preview there. You can see that it overlaps pretty well. If you need further adjustment, you could create a guide curve. I don't need that in this case. I'm just going to hide the sketches of the loft, and as you can see here, this area, it's sharp. So this is what I was telling you guys about. I'm going to add a fillet here. It's a little bit too big, so I'm going to change that and add it on multiple sharp edges at once, so I can edit that and not have to go to the individual sketches to make that change. So that's why I prefer to go about it this way, because probably if I was modeling these from scratch, not from scan data, this is what I would get. So here we have it. You can see how these overlaps. Actually, these strange looking overlapping surfaces, this is something good. You want to see that. That means that you're doing a good job. So this is all for generating the features. We're not going to do the entire thing. The same process you would follow for every single section, and that's all for generating the feature. So let's move on now to creating the deviation analysis, because we have to make sure that the part that we create, it's within certain tolerance of the scan data, and more importantly on the molded part. So let's go back to SOLIDWORKS and let's check this out. Alright, so under the Geomagic for SOLIDWORKS tab, I'm going to go for my deviation analysis tool. It's a little bit different than the one that we have with SOLIDWORKS, and we're going to compare the mesh that we have. It's already pre-selected, but if you had more than one mesh, then you would have to select it yourself. And then for the body to select, you can select it either from the graphics area or from the drop down from the flyout tree, if you had more than one. Okay, so in this case I'm going to choose it from here. And then the next thing that you have to determine is what's going to be your maximum deviation, right? I preset these to 5/1000ths of an inch, so that's going to be good enough for me. And then I'm just going to preview these. It's going to take a while, but SOLIDWORKS is going to give me these graphical report, right? So it gives me the analysis as I want. It gives me here the legend so that I can know using that spectrum what that is. I can tweak these to give me different values and different colors if I wanted to. I rotate that model and I see that it's not really good here, but I don't care about this section because once again I'm going to create that afterwards. Now here I see these sharp edges are not green, meaning I'm not within the tolerance that I want, so I'm going to add a fillet there. Okay, so this is why it's good to run back and forth your deviation analysis. So as you model, create, or as you continue to edit your model, you want to check these back and forth so that you correct all the things that need to be corrected at the appropriate time, and you save some time doing it that way. Okay, so this is not overlapping 100%, but it's still much better than what I had before. So let's go ahead, and it doesn't take long, it only takes a minute. So I'll go back and do another deviation analysis and see how much better these got with the fillet that I put. I'm just watching for 5/1000ths of an inch. And let's see what the report says. So, okay, this looks. It could be better on certain sections, but it's already much better on the upper areas here. Okay, so this is it. You can add more features. You can continue to refine the sketches if you want. I'm gonna exit out of these, and the same process that we followed for this area on the left, we could follow for this portion on the right. The bottom piece, the base, is actually even easier. This is just a boss extrude up to a body or a surface. So you would probably have an idea of how to construct that. These will probably need a couple more cross sections, but really this is it. Going through all of the different steps, this is how we would reverse engineer products that we scanned, and we use the Geomagic for SOLIDWORKS add-in. So thank you very much once again for watching this webinar. And if you want more information, don't hesitate to visit our website, design-point.com. Thank you so much.